Intercepts. So whenever we have a graph of a function, and again, when I talk about graph, I'm talking about the actual graph, the set of all the points. When we talk about intercepts, it's always useful to know where the graph intercepts the x-axis, and in this case, we're generating x-intercepts, and where the actual graph intersects the y-axis. So in this case, we have the y-intercept. Notice that if we're talking about a function, we only have one y-intercept, but we may have several x-intercepts. Because if the function were to have two y-intercepts, then it's actually not a function, and we have seen that before. But it will be a relation, and it will still have a graph, but we wouldn't be talking about a function. So if we talk about a function has only one y-intercept at most. Okay, it may not have one, and that will be okay. And then you can have several x-intercepts. The interesting thing about intercepts is that they occur on the axis, and there is something special about them. The x-intercepts, all the y-coordinates are 0. And this is just a property of being points on the x-axis. If I find the coordinates of this point, well, I don't know how much this is, but I know at least the y-coordinate is 0. For this point right here, I don't know, I may not know what is the x-coordinate, but I know at least the y-coordinate is 0. And the same happens here. Whatever that number is, I don't know, 5 or 10, I know the y-coordinate is 0 for all those points. So for x-intercepts, the y-coordinate is 0 always. And the same happens for the y-intercept. Whenever I have a point on the y-axis, I know for y-intercept, I know the x-coordinate is always 0. And this is useful information, especially if I have an equation, because I know that x is 0, and if I make that in the equation, I can find out how much is the y-intercept and vice versa. So it's 0 always. So definition of intercepts. The x-coordinates of points where the graph of an equation intersects the x-axis, and that's something that you see here. And how to find them, we're setting y equals 0 because that's what we know about the y-coordinate of those points, and so for x. And then to find the y-intercept, we're setting the x-zeros and solving for y. Some people may get confused about this, what to set equal to 0. But just remember, if you're finding the y-intercept, it does not make any sense to make the y 0, because then you found y. So it is pretty obvious that to find the y-intercept, you don't know how much y is, but you do know how much x is. So please stop getting confused with that. So to find the intercepts, the x-intercept, I know that I'm going to set y equals 0. So I write my equation, and then I make y 0. And then I just solve for x. I'm going to add 2. So x squared is 2. And then remember, when I take the square root on both sides, please add a plus and a minus, because you get 2 answers. So x is plus or minus square root of 2. So the x-intercepts, there is actually 2. Positive is square root of 2, 0. And negative is square root of 2, 0. So I know that whatever my graph is, I know that it crosses the x-axis at a square root of 2, 0, and negative square root of 2, 0. You found them, and you don't have to graph them. I'm just making the graph so that you understand what it is that we're finding. And that's all. To find the y-intercept, we're making x equals to 0. So that makes me rewrite my equation. But then on the second line, I'm replacing with this information, 0 squared minus 2. And then 0 squared minus 2 is just negative 2. So that means the y-intercept is the point 0, negative 2, which is over here, 0, negative 2. And since I know this is a parabola, I know that it goes like this. Ta-da! Okay, I'm going to explain what the equation of a circle means because it may look a little frightening the way it's written right now. So let's just try to reason this. Now remember that a circle has a center. Okay, so there is some point on the space defined as the center. And then the actual circle is all the set of points that are a certain distance from this point defined as center. So this point is a distance r from the center. This other point has distance r from the center. This other point is at a distance r from the center. This other point, distance r from the center. This other point, distance r from the center. So all the points that are a certain distance from another point defined as center is called a circle. Are you okay? Okay, good. Hijab is coughing. Anyhow, so you see how the circle is formed with all the points that are at the same distance from a point defined as center. So when we talk about the coordinate plane and we talk about distances, if I have a point here, okay, let's say the point, I don't know, 2, 3. And I define this point as my center. And I want to graph all the points that are away, 1 unit away. Then I can go over here and graph that point, right? The coordinates of this point will be, if this is the 2, 3, this will be the point 3, 3. If I'm going 1 unit away this way, then the coordinates of this point will be 2, 4. If I'm going 1 unit this way, the coordinates of this point will be 1, 3. If I'm going 1 unit below, it would be 2, 2. Okay. Well, actually, it doesn't look like a circle, but the idea is this, right? And all the points that are 1 unit away from this center are forming a circle. So how can I set an equation about this kind of relationship? Well, in general, I'm going to have a point called the center. And the coordinates in general are going to be called h, k. Now, these are just numbers. In here, for example, if I say that my center is hk, for this situation, remember that the center, I define it as 2, 3. H is worth 2 and k is worth 3. If I have another circle somewhere else where I know the center is, I don't know, -4, -5, then h will be -4 and k will be -5. These are just letters that stand for the x coordinates of the center and the y coordinates of the center. I could have called it x, y, but I'm going to choose h and k. So these are just letters. I could have picked any other letters. So if I have a point that is a distance r from this center, this point in general will be called x, y, okay? And I want to have a representation for all the points x, y that are a distance r from my center. So this is another x, y that is a distance r from the center. This is another point x, y that is a distance r from the center, and so on. So the only thing that I have to do now is just apply the distance formula. So what does the distance formula say? That if I have the distance between 2 points, okay, the distance between these 2 points, I don't know, I'm going to call this B and I'm going to call this A. The distance between A and B is the square root of the difference of the y's square, right? So the difference of the y's in here would be y minus k square. And I'm going to add the difference of the x's square, x minus h square. Now, and that's the distance. If I square both sides of the distance, I'm going to get rid of the square root. That's why I have here this part of this equation comes from this part. And now remember that the distance from these 2 points, I'm naming it r, so this will become r squared. So there you go, how we figure out the equation of a circle. All the points x and y are a distance from the center r units. Now it says if the center is the origin, then the equation, if the center is the origin 0, 0, then that means h is 0 and k is 0. So this is 0 and this is 0. So that's why x minus 0 becomes just x, and y minus 0 just becomes y. And the radius of the circle, it just stays as r. So let me give you an example if this is something that it's a little bit confusing. So part A says, find an equation of the circle with radius 3 and center 2, negative 5. So this is just, I'm going to read and I'm going to see what information they are giving me. The radius is 3. So I know for part A, the r is 3. And the center is 2, negative 5. If the center is 2, negative 5, then h is 2 and k is negative 5, because the center in general is written as h comma k. So I know h is 2 and k is negative 5. So now I just have everything I need to write my equation. You can start with x and y. I'm just going to start with x. X minus h squared plus y minus k squared equals r squared. The x stays because it's part of the equation, minus 2 plus y minus negative 5. When you have minus negative 5, that's just plus. And radius squared is 3 squared, which is 9. So what does this mean? What this means is the center of the circle is at 2, negative 5. Okay, that's the center of the circle. And then all the points that are away 3 units are going to be graphed. So from here you go up 3 units. From here you go down 3 units. From here you go down 3 units. From here you go down 3 units. I mean, that other way 3 units. And then you can graph your circle. All these points are 3 units away from the center. And even these ones that are diagonally away from the center, they are away 3. So the graph of this circle is represented by this equation. This equation contains the center and contains the radius, how far away the points are from the center. Now in part B, it says find an equation of the circle that has the points 1, 8 and 5, negative 6 as the endpoints of a diameter. So that means I don't know where the circle is, okay? But I know the points 1, 8, 1, 8, and 5, negative 6 are the endpoints of the diameter. So let's just remember what diameter is. Diameter is any segment that goes through the center of a circle, okay? So I know that the center is going to be somewhere in here. But not only that, I know the center is going to be in the middle of this segment. So the only thing I have to find is where the center is by finding the middle of this segment. And that calls for, and you know what it is, the midpoint formula. Yay! So I want to know where the midpoint of P and Q is. Remember that it would be the average of the x's, 1 plus 5 over 2, and the average of the y's, 8 plus negative 6 over 2. Very quickly, this would be 6 over 2, that's 3. And 8 plus negative 6 is 2 over 2 is 1. So I know the center is at 3, 1. If I know the center, then I know h and I know k. Since I found the center, let me just call it C. The center is at 3, 1. And then to find the radius, I just have to find the distance between P and C, or between P and the center. And then I just apply the formula, square root of difference of the x's squared plus difference of the y's squared. And then I find that it's square root of 53. And then I replace in the formula everything I know. H is 3, K is 1, and radius squared would be square root of 53.